or so, we're going to talk about section 1.8. This is the last section of chapter 1, and then we get on to chapter 2, where we kick it up a notch. Right now it's a lot of review, things we've seen before, which is great. We need to do that. But in chapter 2, we slow down a little, but we get into more heavy material. You get the concept? Right now it's pretty light stuff. So we're going to move on to heavier material in chapter 2. This is the last section of our review for us. And in this section, I'm going to introduce variables to you. You've heard of variable? You've heard of a variable before? We're going to talk about those. We'll talk about also the difference between expressions and equations. So what do those even mean? We'll talk about that in 1.8. So if you're keeping track, we're starting 1.8 right now. Okay, show of hands, how many people have heard of a variable before? Okay, that's everybody actually. So, what's a variable? Oh, what now? It's like a letter. Yeah, it is a letter. Okay, so first part of our definition, variable is a letter. What in the world are we doing with letters in mathematics? Why do we use these letters?
And they like fill in for an unknown number.
Great, so it takes the place of some value that we don't know, or a range of values that we don't know. That's exactly the rest of our definition. So what we're saying a variable is this letter, like usually X, Y, Z, something like that. We can use A, anything we want really. We typically stay away from these letters. We stay away from I, because we use I in a different part of mathematics for something else. We don't really like E. We use that for mathematics somewhere else. We don't like O's because they look like zeros. That would be silly, right? Certain letters we stick away from, but almost anything else we use as variables at some point. So it's a letter that we're going to use to represent a range of numbers.
Doesn't the letter sometimes work off of like what the problem is? Like if there's so many logs, you would use like L or something like that. I've heard of it that way before too. Like if you're working with like there's this many logs and you gotta find this, what is the problem, whatever, and you could use like L.
Sure, yeah, it can represent an unknown quantity. Yeah, that's exactly what we're talking about here. So it's used to represent a range of numbers, or you know what, I'll tack onto that, or an unknown quantity, and or. Or an unknown quantity. I'll kind of introduce a variable to you to give you an idea about one way it's used. Follow me along up here. What's the answer to this?
1.
What's the answer to this?
Undefined. Oh no, 2. My bad.
Oh, by the way, I do want to show you something. I'm going to take a little break here, a little pause. On your homework, a lot of you, though I just graded it, a lot of you did this thing or this thing, and y'all gave me 0. This was one property we talked about for like 5 minutes yesterday. Though I can't have you put 0. I cannot have you do that because that's blatantly incorrect. Whenever you see this, something divided by 0 or something divided by 0, either case, What this is, it's not zero, it's called undefined. There's actually no answer. This is the case where it says you get 12 bucks, put it in 0 bank accounts. How much money is in each bank account? You go, wait a second, I don't have any bank accounts. How am I supposed to be talking about bank accounts? It doesn't even make sense to ask that question. You remember talking about that yesterday?
Yeah.
Not 0. No. Not 0. Not 0. No, it's undefined.
Just put UND or something.
Undefined.
Or like an NA, not applicable.
NA really says something a little bit different. Says you don't even know what this means. Undefined gives us a little better idea. We say that this point doesn't exist on a graph. We can't. If you were to try to graph this function, you couldn't do it. So we're going to say undefined. So whenever you see something over 0, you're going to put what now?
Undefined.
Yeah, that's it. Not 0. Just put undefined. Okay, back to our stuff. One, two. This one?
3.
Okay. Now here's where I'm going to make the jump. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 3 is 3. What's 0 plus anything? How much is that going to be? So if I have 0 plus a, what am I going to get?
A.
Here, a stands for any number you can possibly think of. And that's a way to represent all this information at once. We'd say, okay, well, instead of writing 0 plus 1 is 1, 0 plus 2 is 2, and 0 plus 3 is 3, and giving every possible example, we can list that all at once and say 0 plus a is a. And that does it for us. So here, a is used to represent every number you can possibly think of in the world. So a here is our variable. Okay, next thing we're going to talk about is what's called an algebraic expression. Say algebraic with me, by the way.
Algebraic.
Good. That sounds pretty fancy, algebraic expression. All this really means is a math statement that has variables. A math statement could be things that are multiplied together, added or subtracted, or even exponents. Anything that has to do with numbers combined with the variables put together, that's an algebraic expression. So we're going to say a math statement that involves variables. That statement involves variables, which we just talked about. I'd like to give you a couple examples of some algebraic expressions, just so you see them. Some of them we've already even dealt with. When you see something like this, it's an algebraic expression. It's got the number 7, it has a plus in the middle of it, that's saying we do something there, and it has this y at the very end, which is our variable in this case. So that's an algebraic expression just by its very nature. We could do something like that, 6 times x. Is it possible to have more than one variable at the same time, do you think?
Yeah.
Yeah, we could do something. We could do 3 times b minus 1 plus a. Now, do we know what y is in this case?
No.
Do we know what x is in this case? No, or a or b. We don't know what any of those things are. And you know what? For right now, we can't find them because we don't have what's called an equation. You're going to learn the difference between an expression and an equation probably tomorrow, where we talk a lot about that. But for right now, we really cannot solve these. You can only solve equations. You can evaluate. Remember that word evaluate? I taught you what that meant last time. It means plug in numbers and figure out a numerical answer. We can evaluate expressions, which we're going to do in just a second, but we can't actually solve them. We can't find out what the variable is. You can only take numbers and plug it into the variable. Do you see the difference? We can't solve these things. I'll show you solving at a later date. For right now, we can just manipulate them. Okay, one more thing before we get into evaluating, and that's this. We need to know what that actually means when I say 3x.
3 times x.
Yeah, there's an operation there, and you're exactly right. Whenever you have a number next to a variable with nothing in between it, what it is implying is that you're going to multiply the 3 times whatever value you substitute into x. That's a multiplication problem right there. Nod your head if you're okay with that. That we're actually supposed to multiply there. Good, okay. So what 3 times x means, or what 3x means, is 3 times x. So if you look back at these problems that I have up here, these expressions, is there a different way I could write 6 times x?
Yeah,
Just
6x.
Great. There's also a different way I could write 3 times b. I could just write it.
3b.
Perfect. Yeah, that's exactly right. So when we see this, it's synonymous with 3 times x. Also, this works if you have 2 variables right next to each other. We mean there, you're going to take the x times the y. Hey, also, we haven't talked about this yet, but do you suppose that exponents work with variables as well?
Yeah.
Yeah. So when I say, how would I say that, by the way?
X
X squared.
X squared, that's how I'd say it, or x to the
Second power.
perfect. And what it means is, I think, Jeff, you had that, it was
X times x.
perfect. Not x times y. I made a mistake there. There. X times x. And we can do this with any exponent we want. If we add y to the 5th, that would just be y times y times y times y times y, all 5 times. So the same idea of exponents works also with variables. Now, we're going to talk about this thing called evaluation, how to evaluate expressions. And we'll end there today. Here's what evaluate means to you. It means substitute, or you can think of it kind of like plugging in. It means plug in the number I give you to the variable that's shown in your expression. Are you guys with me on this? I'll say it one more time so it kind of sinks in. Evaluate. I'm going to say that on your test. And if you don't know what evaluate means, you might not know what to do here. So whenever you hear or you see the word evaluate, what it means in math is you're going to take the number I give you, plug it into the variable in your expression, and work out to get a solution there, okay? Oh, well, not a solution, a numerical answer. That's what you're trying to do. So evaluate means plug in a given number to your variable. Let's give this a try. We're going to start off kind of slow to make sure you really understand the idea of evaluation, and we'll work our way up. So if I ask you to evaluate this, evaluate 2x when x is equal to 13. What the evaluation part of this says to do, it says, firstly identify where your variable is at. What's our variable in this case?
X.
And then the second statement is going to tell you how much x is worth for this one problem. How much is x worth here?
13.
Okay. So what we do is we rewrite our expression.
2 times.
Yeah, we're substituting. We're plugging that in. We're going to rewrite our expression, except instead of our variable, we're going to write the number that it's worth. So does the 2 change?
No.
No.
What did the 2x mean again?
Times.
Multiply.
So we're putting that times, and then the x becomes
13.
Sure. Then we work the problem out. So wherever our variable is, we're taking the the quantity of that variable, how much it's worth. We're plugging it into that expression, and then we're going to evaluate this, which means work it all the way down till you get one number. So 2 times 13, how much is that?
26.
And that's our numerical answer. Are you with me on the whole evaluation thing so far? This is pretty not so bad problem, right? Because it's only one step. But we can make them a little bit more involved. So don't worry. I know you were worried about that. Don't worry. We'll get there. Is it okay to have two variables?
Yeah.
As long as I give you two different values, sure. So we're going to evaluate 2 times the quantity x minus y when x is 7 and y is 3. Tell me the first thing we're going to do.
You change the x.
Great, okay. So we're going to change the x and the y. We're going to do that without doing any math in our head. We're just going to really rewrite it. That gives us a good understanding about what we do next in our problem. So we're not going to try to plug them in our head and then do a whole bunch of math and try to get an answer. That might work for the first couple, no problem. But when I give you a really kind of complicated problem, it's not going to happen. So here we'll rewrite the 2 stays.
Yep.
Yeah.
Does the x change?
Yes.
What?
7.
Does the minus change?
No.
Does y change?
Yes.
Now we got an order of operations problem we've just accomplished doing. So we'll keep our 2. We know to do parentheses first, that gives us 4. And then we finish off our multiplication and we get, that's exactly right. Let's try a couple more. I'll give you something to do on your own, then we'll call it a day today. Okay, tell me what to do. What first?
You
Okay.
change the x and y.
What goes where? Why don't you tell me exactly what I need to write? Someone left-hand side of the room over here. You guys. Someone tell me exactly what I need to write right now.
35
Great, okay.
5 is the
minus 5 times 5.
5 times 5, that's great. So we substitute in the 35 for the x. The minus 5 stayed the same. The 5 for the y. Do we still have a fraction mark?
Yes.
Now what's going to go on the bottom?
5.
Good. Now we have another order of operations problem. So when we work these out, I'm going to go through this quickly because I know you know how to do this. We just covered that. But what we would do is we do 35 minus 25, of course, because we have multiplication.
10. Oh, there you go.
10 over 5.
We're going to have 10 over 5. That's going to leave us with 2.
Yes, sir. That's 25 minus z cubed plus x when z is 2 and x is 9. Tell me what I need to write.
25 minus 2.
25.
2 to the third.
Hang on, I'm slow. 25 minus, great. Okay, we got that part down, that's not changing. The z becomes a what?
2.
2.
2 to the
Is it still raised to the third?
Yes.
Yes.
And then what?
X
Plus 9.
Great, plus 9. Then we work it out. How much is 2 cubed, by the way?
8.
8.
Which one?
Wait, what?
8.
8.
Okay, why?
Because times 2. 2 times 2, 4 times 2 again will be 8.
Good. You know, it's easy to do that, though. Don't get mad at yourself now. It's easy to just look at it and go, oh.
You're back to the basics.
That's what your mind
Your brain's just, your brain's programmed.
Exactly, yeah. You see the 2 and the 3 and you want to go, oh, that's 6, easy. Come on, Leonard, give me something tough. And then you go,
No, Leonard, don't do that.
Don't do that yet. Okay, and then we add first, right?
Yes, sir.
Oh, I caught you. Did we add first in this one?
No, you go left to right.
Definitely left to right. If you add first here, you're going to get something way different than the right answer, that's for sure. So we're going to subtract first. 25 minus 8 gives me how much?
17.
Add that 9 and you get 26.
Okay, how many people feel pretty good about what we talked about today? Good. Next time, I'm going to give you, just like I did today, kind of a, well, before you pack up, that's really annoying, just so you know.
Sorry.
What we're going to do tomorrow is I'm going to give you a list of problems like I did today so you can start on kind of a warm-up. And it's going to be a valuation problem. So we're going to refresh your memory on that tomorrow. Then we'll cover some equations and translations. That'll be a great day tomorrow. Guys, did today make sense for you?
Yes.
Have a great day. Your homework is due tomorrow. Okay, so there's some problems on the board we're evaluating. Remember, evaluation just means plug those numbers into the variable that they correlate with and figure out a numerical answer. So let's go through that. Plug them in first before we do the math. I'll be walking around. If you need any help at all, just raise your hand, I'll help you. Okay, so let's get started up here. So really the idea is plug the numbers into their variable, see what you have, then use order of operations to figure this thing out. So in our first case, it says x is 8 and y is 7. So we're going to put, instead of y, we'll put our 7. We'll have, instead of x, 8. And we do order of operations, which says we're going to do the parentheses first. We should have on your paper 7 times 5, and our answer is 35. Did you get 35?
Yeah.
Good, all right, fantastic. Next one, very similar idea. Y this time comes second here, so we're going to have 18 plus 6. We'll have this over 6. If we add those together, we'll get 24 over 6, and our answer is 4. Did you get 4?
Yes.
Good deal. Okay, last one involves a little exponent, not a big deal. X squared, we're going to do, instead of x squared, it says 5 squared. Plus, instead of z, we'll put our 4 and wrap that up with the minus 3 like we're supposed to have. So we do our order operations. Exponents first says we get how much?
25.
Yep. Of course, we'll add first because we're going from left to right. So that means we're going to get 29. And then when we subtract the 3, after we subtract that 3, we're going to get 26. Yep. Good. How many people were 3 for 3? Got all 3 of those right. Good. That's fantastic. Good job. You know, there's one more I want to show you. Do you know there's 2 different types of measuring temperature? I'm sure you do. What are they called? Which one do we use?
Fahrenheit.
Which one does everyone else use?
Celsius.
Yeah, isn't that weird? So there's actually a formula for doing that, and it's an evaluation problem. Here's how it looks. It says if you take 5 times F, which stands for Fahrenheit,
subtract 32 from it, divide by 9, you'll get the Celsius equivalent for that. So let's say, let's be optimistic and say it's going to cool down here someday. Let's say it's going to get to 41 degrees outside Fahrenheit. We want to figure out how much 41 degrees Fahrenheit is going to be in Celsius. What's the plan? What do we do?
You do the parentheses first.
What do we need to do before we even do parentheses?
Well, put 41 where the F is.
Great. So basically it's just an evaluation problem. Well, this time we have a temperature. So we're going to plug in 41 to F. How much is the 41 minus 32?
9.
So we'll have 5 times 9. The order of operations say we do that parentheses on our numerator first. We do our 9. Of course, we have the multiplication here. How much is the 5 times 9? What'd you say?
45.
And someone else, what is 45 over 9? How much does that give us?
5
Good. What's that mean?
degrees Celsius.
So if you're thinking about this, if someone else says to you, man, it's only 5 degrees outside, and they mean Celsius, to us it would feel like 41 degrees Fahrenheit. They're the same value, it's just we have different ways of communicating
Cool
that.
down to 41.
Hmm?
You said it'd cool down to like 41. I just got.
Being
that's like-
optimistic, Jeff.
That's pretty cold.
I know, right?
For a normal day, it's like a nighttime.
Yeah, it doesn't even get down that low at night.
Yeah.
It's like 66 at night,
If we're lucky.
if we're lucky. Yeah. It was
Not this
61
week.
last night.
Oh, it was.
Yeah. In between Merced and Chowchilla. My temperature thing said 61.
Wow.
Yeah, I know. I was just going to stop there and enjoy it.
I live in Florida.
So it's always cold.
It's cold.
Whatever. We're all burning down here. You
But
guys
it's
are
no.
comfortable. Yeah. Anyway, do you understand the idea of going between Celsius or Fahrenheit and Celsius?
Why do you put Celsius?
That's the whole operation here, is that this formula is converting Fahrenheit to Celsius. That's what it's doing. So you plug in any temperature you want to convert. So here we said 41 degrees Fahrenheit. We do this math on it, it'll give you out a temperature in Celsius.
Why?
That's the way, that's the conversion for it.
The rest of the world is on Celsius.
Always 532.
All these numbers stay the same. Yep. So any temperature you want. Say you want to convert 100 degrees Fahrenheit. Plug in 100. Do the same math. It's going to come out. The only problem is I had to give you a number that we can't get a decimal on yet because we haven't covered that. So I gave you 41 because I knew 41 minus 30. That's just 9. It's easy to divide. But you can do this with anything. If you have a calculator, it's even easier. Good question so far. Thanks for the questions. Any other questions that we have? All right. The last thing we have to do in our section, besides translate some statements, we have to talk about equations. We've already talked about variables. We know what those are now. We've talked about expressions, but what we haven't got to is equations. So we'll talk about that for just a second. What an equation is, I mean, you get this from the word equation. The key word there, what's the key word in equation? Equal. Yeah, equate or equal, that's right. So what this is, an equation is just a statement of equality. What that means for you is this. This is the important part about it. Anything that has an equal sign is an equation. Anything that doesn't have an equal sign is an expression. That's the difference there. Equal sign, equation. Not equal sign, expression. The thing we're going to find out later is that we can solve equations. We can only evaluate expressions. We can do this all day long with expressions, plug numbers in, but we can't ever solve them and find the variable independently. We cannot do that. There's no equation. So that's what we're going to use equations for, is actually solving. Which one can you solve again? Equations or expressions?
Equations.
Equations, yeah. Which one has the equal sign? Equations or expressions? Do expressions have an equal sign? No. These are expressions. What we've been dealing with the whole time. No equal sign. So equations, what I'm going to put up here is they're statements of equality and therefore have an equal sign. They have an equal sign. I'll put right underneath this. Expressions don't. They're just statements like what we've had. Let me clear this up a little bit. Firstly, equation, expression.
Expression.
Okay, good. Did you all agree that's an expression? How much is x?
Whatever number wants to be.
So you can't just tell me what x is right now, can you? Not until I do this. What's that become right now when I put that up there? Equation. And now you can probably think of what number would fit in that x spot. So let me ask this question. Is 4 a solution? A solution is a number that makes a statement true. Is 4 a solution? Why not?
That'd be 13.
Okay.
11 equals 12.
So if I put 4 here, yeah, we get a 13. They would certainly not be equal, and that's what an equation has to be. So well, I'll define the solution for you if you're not clear. What we say solution is just a value that makes your statement true. That's what we're talking about. A solution is a value or values that will make your equation true. And sure, we could try 4. I mean, we just did. You probably did in your head. But if we tried 4, like, is 4 a solution? I'm going to abbreviate here. Is 4 a solution? How you would check to see if 4 is a solution, take that 4, plug it into your variable, and see if it's equal. If we tried that here, if we plugged in 4, y'all gave me the answer already. But we'd have 4 in place of our variable plus 9 equals 12. And if we work this out, we'd have 13 equals 12. Is that right? We put a line through it and go, no, that's not a solution. So our answer to this question would be no. And for right now, that's how we're checking to see if something's a solution or not. In the future, I'll give you some great steps on how to solve any equation you ever come across in this class, or probably Math A, and most of Math C. I'll give you all those steps. It'll work all the time for you. That's great. But for right now, all we're doing is checking to see whether something's a solution or not. How you determine that, plug it in. If it works, if it makes it true, it's a solution. If it doesn't work, like this case, then it's not a solution. That's the difference. Some people understand what a solution is. Good. Okay, you said the solution is, what was the solution here?
3.
Yeah, 3. Because if we put in 3, 3 plus 9 does give us that 12. So what we'll say here is x equals 3 is a solution. One last question for you, some on the right-hand side, my right-hand side. Are there any other numbers that work?
No.
Even negatives aren't going to work here.
Multiple numbers.
What do you mean?
X could be 2 plus 1.
Okay, yeah, I mean like single like value. Yeah, you're right, it could be, right? But if we're taking one number and plugging it in there, is there anything else
No.
besides 3 that's going to work?
No.
No, you're right. Yeah, that's the only solution in this case. Oftentimes in this class, we're going to be down to getting one solution. And that's pretty much it. In Math C, you start getting 1 or 2 solutions. In other classes, you get more than that. And I can give you some knowledge about that when we get on into solving equations, which we will. But for right now, we'll be getting one solution, and that's the only number that's going to work for us. Let's try a couple more. Don't answer out loud. I don't want you to know that you know it right now. I want everyone to have a chance to think about this. What I'd like you to answer is this. Do this on your own. Don't say it out loud. Is 8 a solution? Is 8 a solution? Check it out. How would you find that out? Well, we just learned we can plug that value in, do the math on it, and see if they're equal. If it is, then 8's a solution. If it's not, then 8's not a solution. Try that on your own right now. If you're done with that one already, try this next one. What I'd like you to do is determine which of these ones are solutions. It's either 10, 6, or 8. Find which one's a solution. Don't tell me out loud, just do it on your paper. By the way, I've looked at your homework. Your homework's pretty good. I've graded it all. I just keep forgetting to bring it to class. Darn it, bugging me. But I have it all graded, and it's looking pretty good for most of you. Most of you know what I expect you to know, and you're picking up the new stuff. So congratulations on your homework. That's great. You will be getting it back starting on Monday. I just have to put it in the grade book and then get it back to you. So good job so far. Very good. Okay, let's look at the first one. Is 8 a solution?
Yes.
How did you determine that?
Mean 8 y.
Very good. That's exactly right.
6 equals 2 times 3 equals 6.
You said make the 8 in for the y. Good. And then what'd you say?
You get 2,
Uh-huh.
and you multiply it times 3 equals 6.
So when we get down to here and we say 6 equals 6, we go, oh yeah, that's true. That's a true statement. And the answer here is yes then. So we just answer yes, 8's a solution, we're done. Next one, we got to determine which one is a solution. So there's 3 to try. Did you try the 10? If you try the 10, I mean, you really could kind of think of this in your head. If you try the 10, that's already 50, right?
Yeah.
That's way more. If you try the 8, that's already 40. That's more. Try the 6. 6 gives you 30, and then we add the 4. The 6 is going to work. And in order to show that, we do 5 times 6 plus 4 equals 34. Of course, 5 times 6 order of operation tells us this is 30 plus 4. And sure enough, at the very end, we get 34 equals 34. The other ones would not have done that for us. So our solution here is 6. Do you feel okay on finding out what solutions work? How many people feel okay on finding out what solutions work? Good, good for you. The last thing we do in our section, we're going to talk about how to translate word problems into math, because I gotta be honest with you, that's like the hardest part in math for a lot of people is doing word problems. Do you like word problems? Nobody likes word problems. Why? Because they're hard. They're not like this where you just do it. It's not just numbers. You have to translate it first, and then you have, it's like putting English together with math. Who would have thought? I mean, come on, what's that about? You have to translate it and then do the math itself, which the translating is the hard part. So we're gonna start off slowly. We're not gonna start off with the massive word problems right now. We will get to word problems later, I promise we will. Hard ones, and you'll be able to do them just fine. But for right now, we're going to start off nice and slowly. We're just going to be translating some expressions. I want you to get used to these words, like increased by, quotient, product, sum, things like that, so that when we get onto those word problems, you have an easier time. Does it sound like a good idea to you? Say yes.
Yes.
Okay. Some of you are zoning out already. You got to zone in. I only need you for 25 more minutes. Okay? Just focus in for 25 and you get a weekend. What I would like you to do on your own time, go home, look at page 78, write that down. Look at page 78. There's some words that I need you to memorize. Okay, all the what they mean, like the words like increased by, the words like decreased by, or quotient, or subtracted from, or less than. All those things you need to have in your head. That way when we talk about them, you know exactly what it means. So we're going to go ahead and do some examples right now. We'll do about, 6 of them together. I'll give you about 5 or so to do on your own, and that should really give you an idea about a lot of the words we'll be using in this class. You with me on this? Okay, let's do this thing. 78. Yeah. Do y'all have any questions on solutions before we, or equations before we get started on this? All right. So we're going to talk about translating right now. I'm going to give you a way to do word problems that I hope is going to help you out. What we do with word problems is we do a lot of underlining and translating piece by piece. That allows us not just to have to look at the whole thing and figure out what it is in one fell swoop, because it's very hard to do, especially when you have more than one sentence word problems. It's hard. And so here's an option you have in order to kind of translate any word problem you get. First thing, when we write it out, we're going to get some statement like, let's say it's 17 increased by a number. And what we're going to do piece by piece is underline the parts of these sentences that mean anything to do with math and translate them accordingly. So when we read through this, we have 17, sure, that's a number, increased by a number. So 17 increased by a number. Tell me something up there that means a mathematical operation. Can you tell me that?
Increase.
What's increased mean?
Plus.
So we're going to underline that word plus, or underline that word increased by, and right under we're just going to put a plus. Just so we have in our head right now that increased by means we're adding something. What does it mean by a number? Yeah, it doesn't mean you get to pick your number, right? It means they pick the number, but they haven't told you what it is yet. So, what now? Like a letter. Anything you want. We're going to stick away from like 0 or like O's or I's because they look funny to us. But what's a typical variable that you want? Yeah, you pick X, you can pick P, and whatever. Be creative. Don't pick X all the time. That's just boring. So let's pick some fun ones later on, but we'll pick X for now. So we're going to underline every word that means math. Increased by means plus, a number means a variable, and then we can translate this down. So instead of actually having to think of it all at once, we have this. We have 17. We know this means plus. We know this means a variable. Can you now write this pretty easily?
Yeah.
How much is it going to be?
What's that?
17x, 17 plus x?
17 plus x.
That's it. That's exactly what that is. Let's go through the same process. This says the product of 7 and a number. First thing, tell me something up there that means some math to you.
Product.
Great. What does product mean?
Multiplication.
Great. Okay. So product of means we're multiplying somewhere with a little dot. What else means something up there that we need to translate?
A number.
What do you want to make it?
Y.
W. I like W. J's. Oh, I like J.
M.
So the product of 7 and a number. Now this one's a little bit different than this because the increased by gave the number first. This one says the product of, and then it gives you two things. These go in the same order that they're written. Please listen carefully. This is not always the case. Sometimes you're going to get some things that look like they're backwards. This happens with when you do like more than or less than. Those things are written in a sentence, but you have to write them almost what you are going to think is a backwards way. This one's written in the appropriate order. So here we're going to do the product of 7 and a number. It's just going to be 7 times j. And we're going to get,
7J.
yeah, we don't really write the times between there. I think I have enough room here. I'll try one more. Ten decreased by a number. 10 decreased by, what's the decreased by mean to you?
Subtract.
Great. Increased, addition, decreased, of course, subtraction. A number, we're going to pick a variable there. Someone else pick another variable.
P.
L is good. So we'll have 10 minus L. Now the reason I do this one is because I'm going to compare it to the next one we have. This is the one where 90% of the people who take my class, take most Math 80 classes, they mess this part up. Hopefully you won't be part of that 90%. Here's what it looks like. Happens, I explain the same way every time. It just so happens that this is a hard one because people see, you'll see. Now I know what you're thinking. You're thinking, well, duh, Mr. Leonard, this was pretty easy. Subtracted from should probably mean minus, right? And it does, you're right. And a number, well, that's duh, that's like a variable y. But you know what? If you put this, you just got the problem wrong. If you put this way, you just messed up this problem. And when you do this in a different situation where I add on more things to this, like I'm going to say 4 times the product, or 4 times 5 subtracted from a number divided by 2 times the quantity of x plus 3. If you screw up this little part, you're going to get the whole thing wrong. Do you see what I'm talking about? This is not just our end here. This is not where we end. This is just a little piece. You have to get this piece right so you can move on. If you do 5 subtract from a number, put 5 minus y, which that happens a lot when you're going quick. You say, oh, subtraction, I know this. This is not exactly right. I want you to think of what subtracted from means. If I say you have 3 subtracted from 20, how much do you have? You all just answer that question. 3 subtracted from 20. Did you do this? You didn't just do that, did you? Because that would be negative 17. We haven't even got there yet. So 3 subtracted from 20. Here's what you did in your head. You did, okay, I have 20, and now I'm subtracting 3. That's 3 subtracted from 20. This one, and the next one I'm going to write, and the next one after that, are written backwards from what they should be. Okay, what you think they should be. The subtracted from means it comes at the end. So whenever you see subtracted from, what we're going to put up here is, if it's subtracted from, yeah, it's minus, but it's going to be minus 5. That's coming at the end of it. Maybe that'll help you out a little bit. I hope it does. So 5 subtracted from a number, it's not 5 minus y. It's not that one. It's y minus 5. This is 5 being subtracted from a number that I give you. How many people understand the difference between those two? Okay, that's important. The other one that works the same way as this. Yeah, subtracted from. It means you add the number first and you're subtracting from that. I know it gets a little confusing, right? Because you want to write it in that order, but let's do. This one is the same way. That less than idea is the same way. If I say you have 7 less than 15, think about this one. If I say you have 7 less than 15, how much do you have?
Minus 7.
Right, how much is that? So if I say less than, it's the same thing as a subtracted from. If I say 7 less than 15, what you're doing is 15 minus 7. Here I'm saying 7 less than a number. Let's pick t. Less than means minus, but it means the same thing. Minus that number. Yeah, Jack.
Isn't there a less than the one thing?
Yeah, there is a less than, but that's a different context.
Why are you writing negative 9?
We're saying that we're writing this in the correct order. Less than means I'm going to take this number away from here. If I just write it like this, we now have the wrong thing.
So then you're going to put negative 9 and then just t next to it?
No, what we're going to do is we're going to write the t, and then we're going to take 9 less than that. It's written in that order. The t comes first in this case, just like the subtracted from. That's a good question. Any other questions? They're all good. You do need to understand before we go any further, so if you have more, ask. Yeah.
Only in subtraction that happens, or in all of them?
In subtraction, it depends on the wording. You see, when we had like decreased by, we had 10 minus L. There's a couple ones you need to watch out for. It's subtracted from, less than, and more than. The thing about more than, it really doesn't matter because it doesn't matter how you add mathematics. But I do want you to write in the right order. The subtracted ones, the subtraction ones, those are the ones that are going to get you. Okay? Does that make sense to you? The products don't really matter because it doesn't matter how you multiply. The division does, right? But quotient is in the proper order. That's okay. The ones that really mess people up, I've just told them to you, are subtracted from and less than. Those are the ones that get people all the time. Glad you had okay with that. Okay, so are you going to watch out for subtracted from and less than? Yeah. Everything else is okay. Decreased by, yeah, write it in that order. That's fine. That's cool. But here, these are written backwards of how they're written in the sentence. So instead of 5 minus, we're doing y minus 5. Instead of 9 minus t, we're doing t minus 9. That's subtracted from and less than. Notice how the subtracted from is referring to the second thing. Do you see that? Saying, I'm after that. The less than is referring to the second thing. It's, I'm after that. Okay, I'd like to give you about 5 on your own. Let's see if you can translate these correctly. Okay, let's stick with 4. I think that'll give us a good idea of what's going on. I'll be walking around. If you do need help, just raise your hand. I'll come help you.
Okay, lots of good work. That's good. Okay, the quotient of a number and 10. Now, we haven't talked about quotient a whole lot. We've mentioned it only a couple times. What is a quotient?
An answer.
Divide.
An answer that
Division
implies
problem.
word division. That's right. And a number. What'd you pick?
And
H.
Jeff, you don't got to talk over people. She already got it. So the quotient of a number and 10, the quotient goes in order like a sum or a, well, I already gave that one away, like most of the other sentences do. So the quotient just says the first one divided by the second one. I would like to see you write these as fractions. You can write them as n divided by 10, that's fine, but also translate that back to n over 10. Have both those ways down in your head. I want you to know that. Let's go on to the next one. 4 more than a number. What's more than? What's that mean?
addition.
Okay, so we're adding somehow. We're going to underline that and put plus. A number, I'll pick k. Now, does it go 4 plus k or k plus 4? What did you guys put? Why? Explain that. Why would it be 4 plus k? Wait, no?
More than a factor.
That's right, it is. It works just like less than does. Remember, less than says it's referring to the second thing. It's coming after that. Now, this is appropriately written. 4 more than k would be k, and then you're doing 4 more than that. The difference between this one and the less than one is this. Addition is commutative, which means you can flip it around and it doesn't make any difference. Do you understand? So if you get this one wrong, it's not going to come back and really kill you. If you get those ones wrong, it will. I would like you to write it as k plus 4 because that ingrains it in your head and makes sure you really get it, that you're adding 4 to the end of a number. The more than says, go to that number, take 4 more than that. That's why it's at the end of that. But it works the same as a less than. It's just not going to have as many problems as if you messed that one up. You with me on this, folks? Okay.
So you want like that?
I want it like that. Okay. For the more than, yes, it goes at the end. It's just like the less than. How about the sum? What's the sum do?
Multiply.
Add.
Addition.
Okay. A number, which would be your number? The sum of a number and 7. What happened?
There's a rat on the
Oh, oh, what now?
There's a rat.
Seriously? That's really gross.
Cool.
I dare you to catch. No, don't catch it.
You did
I
say
know, right? Don't catch the rat. Okay. Yeah. Okay, the rat's not the show. I'm the show. Let's go. Come on. It's just a little. It's smaller than everybody in here. Don't worry. It's a little thing. It's maybe more hair than all of us, but that's all right. So we got the sum of a number and 7. A sum means addition. Now the sums mean you're doing this in order. So sum, we're just going to put p plus 7. It goes in the correct order like we think that it should. Did you get p plus 7?
Yeah.
Okay, now the last one that we're going to do, 10 less than a number. This one is the important one on this set, the quotient and the less than. Less than does mean subtraction. A number means anything that you want it to pick. How about b? 10 less than a number. Are we going to write this 10 minus b or b minus 10? Very good. The less than comes at the very end of it. For me, I like to do this. I like to think of it as minus 10. That way it sticks in my head that I'm just going to do b minus 10. How many people feel okay with what we've done today? Feel okay with somewhat? Get most of them?
Yeah.
That's good, all right. You'll have some practice tonight. You're going to be doing some translated expressions. We'll be dealing with some equations. You feel good about the whole equation idea? You now know how to check solutions on your equations, right? Okay. The next thing that we're going to talk about, we're going to talk about integers. Have you ever heard of integers before?
Yeah.
Are integers positive or negative, or could they be both? What do you think?
Maybe both.
So we're going to deal with positive and negative numbers. We'll see how to add them, multiply them, divide them, all sorts of stuff with it. But we're going to start that next time. We're going to end. It's a good spot for us to end right here.